We're gonna make this happen somehow. I'm not gonna lie. I've been procrastinating this all day. Oh, I did have some other work to get done that I was working on, but oh man, I just, in case it wasn't clear for me saying it about a dozen times now, I just want to get this part done. I just want to get to a solution that works good enough. But I think we're so close. Oh, all right. So, and I don't know. I mean, again, I don't really want to talk through this that much, to be honest. Hold on, what is going on here? Do I have something is wrong with the lighting? Give me a second. That's at its normal level. Is this not right? Hold on. That feels a little too hot. Yeah, it's just a touch too hot. Hold on. All right, back. Wait. We back it off a little bit now. That doesn't feel right. Okay, you know what I'm gonna do? I'm going to go to. Let's see. What are we at here? Oh well, whatever. We're going with it. So let's go ahead and pop it out, my friends. Get a little Mr. Mountain Dew. No, something is definitely wrong. What is wrong? Can somebody tell me what's wrong? Why do I feel like... Is it... Is it that? The lighting's off. I know it's off. But it's okay. I'm going to let it go. Oh, but the network should be good now. Yeah, that was the reason I never came back yesterday, aside from just procrastinating this, because it's so hard to mentally get into this, and then it's not very rewarding because I'm not actually making the progress that I want to make. So it's really, really hard. But oh, there's our open focus from Mr. Mountain Dew. But yeah, figuring out the network stuff was far more interesting. And now I've got my network segmented. I still need to test the TV, and I have to re-add the printer. But the main thing is that... Oh, dang. I'm going to have to check this out. What was I going to say? The main thing is what? The main thing is there's something. There's something and it's the main thing. Oh, I had to restore my network config from a backup. I don't know exactly what went wrong. I mean, I have been making a few changes, but I don't think any of the changes were... I mean, obviously something was related to making the network really crappy on the WAN side somehow. But I don't know. I was just... Anyway, so I restored a backup from February, which, kind of messed up everything because that was back before we started doing anything with servers. And so anyway, just a whole bunch of config got wiped away. I was going to do a factory reset, but I couldn't do a factory reset on just the networking. I would have had to reset the cameras and the other stuff too. And so instead I was able to do a backup restore of the networking. And then I just kind of rebuilt the network, and I learned about some more firewall rule stuff, and now speed test is good again. I expect that the stream's going to be great. We're not going to have bunches of drop frames or jit or lag or any of that this time. And uh-oh. Okay, are we good? Okay. What? Okay, no. Now the sound's back. Okay, I'm going to close this out and open this back up. Whoa! Okay. Can I just hit enter? Oh, thank goodness I can just hit enter. Alright, so sound bugged out for a second. I'm just going to close this and reopen it. Ugh, that's not what I wanted. Okay. Alright, let's bring this back over here. Let's see if we can get the sound working again. No. There. Got this. Okay, let's see again. Alright, looks. Okay, now it looks like everything's back. I don't know what happened there. I think that was just a momentary glitch. I hope. Okay, I will need to update that software. Anyway, so now I have things like my TV are separate from this network. I now have a business network that's separate from the home network. So I have a business network, a home network, a business lab, home entertainment, and then untrusted IoT devices. So there's this Wi-Fi switches that I bought because they were cheap and people said they're fairly configurable, and then started looking into them and I realized, oh, they also are doing that. They're also potentially command and control bots. And so I unplugged them and I just didn't use them because once I got them because they weren't connected to Google or Alexa or any of that stuff. But then what they are connected to isn't any better. So you can control them from your home, but it requires more work and you have to overwrite their. They have they phone home to their Chinese company or whatever, and you can override that. Oh, excuse me, but you have to do a little bit more work, and because I didn't understand all that. Anyway, so point is now they're on an isolated network where I can contact them, I can send them a control signal, but they cannot. If they were to turn into command and control bots, they could not get out to any of the other network. They're firewall isolated. They're basically kind of considered like a WAN. They don't port forward or anything into the main network. They have a separate IP range. So that was cool to figure out. Anyway, so here we are. What's going on? Total face value. Oh, dang it. This is when I went to dinner. Okay. Oh, that sucks. I had to go. Oh, okay. So what were we trying to do? I needed to update total face value, I think is what it was. This is going to say, okay, denom info.face value. There we go. I think that's what the goal was. And I think there was one other thing that needed to change there too. Selected face value. Was it? No, total face value wouldn't change. Selected face value would change, right? And then we would need to rerun this calculation right down here. Yeah, okay. So total face value stays the same. Selected face value changes. And then we'll rerun the calculation again. Okay. So let's run this test. Oh. Cool. So that works out. And so basically we've selected the most favorable set of coins at this point. I'm trying to remember how I knew. So we've got one more rule to implement, and then we're done with this, and we're going to pass it off, and this is going to be good enough for now. So it's I believe it's going to be way better than the current selection algorithm, which is basically just try one bigger and then accumulate tons of tiny ones. We should not, with this, again, this is me going off of my intuition to some degree, because I'd have to have access to lots of wallets, real wallets, and I'm going off of kind of anecdotal experience. So I think that this is... I know that from anecdotal experience, there's a problem with people having tons and tons and tons of small coins, and then having to aggregate them hugely in order to spend them. This should solve that problem, because rather than always trying to get the coin that's a little bit bigger to spend, this is going to try from the most strange coin and then the smallest slotted coin and work that way. So this should make it so that we tend towards not having lots of junk tiny coins. I think. I mean, I don't know how to prove it, but at least I know that we're selecting those intentionally. So that's good. Yeah. This should be far better, and then get better as it gets more adoption. Okay, so we've got that going for it. So first phase is try to make exact change. Next phase is add in the value that makes the least change, not necessarily the value that's the closest, well, by least change, lowest value, yes. But there could be something that has least change is the most important. So it's going to group first by things that make the least change. So that's important. Then it's going to group by things that, of the things that are the least change, pick the thing that has the lowest value, because again, we want to spend the lower value units. We want to prioritize spending the lower value units, so that we're not stuck with excess lower value units. So I think that's correct. And we had a test for that, so that's good. And then the only thing, this is the line that I needed to get in before dinner to make this all work, that I wasn't able to get in. There's just that one line right there. Okay, so now from that, bless my... All right, now we should have the selected coins. So I'm going to take a look at this again. All right. And there's a few things that we're going to need to do that I'm not quite sure how we do. Let's see. So I think we want to run this version. And if this gives us enough to pay, then we'll use this version. But then we can increment by the smallest. Basically, we can keep incrementing by the smallest denomination until we can pay, and then we can increment the smallest denomination again to see if it ends up with less change. Because there is an edge case that needs to be accounted for, to where this can seem like it's going to succeed, but it's going to fail. Because we still have the same problem that we've always had, which is that in order to know how much a transaction is going to cost, you have to calculate all of the things about the transaction, which may change what the transaction is going to cost. So here, once we've calculated everything, we need to make sure that two conditions are met. One, that at minimum we can send to the other party what they requested. And if they requested a bunch of trailing numbers, that's just going to be in the stamp values. Number two is that the fees pay for themselves and don't cause basically that there's also enough to pay for the fees and stamps. If that's not the case, then and this is another dimension in the selection algorithm that we could pick, which is, well, aside from face value, what's the stamp value? Because we may want to pick something that has a slightly higher stamp value. But again, let's see. Okay, so we need to check, can it pay even the little bitty parts, because that's something that we didn't worry about in this calculation, which maybe at some point we should, probably with the total value. I think that's where maybe that should come in a little earlier. Yeah. Okay, so we need to figure out, can it actually pay at least the exact amount that was requested, all value considered, plus its own cost. And then I'm trying to think of what layer I want to do this. This may be something where, just like the other one, we want to build up the fee as we go. Okay, but in any case, I'm going to need to have another one. Whoops. where let's go into that test again. Wasn't it? Send value. There we go, because send cache like. Alright, so this is what we need to do. Oh, bless me. So I need to increase it to where selecting one of a higher value won't be enough. So I think for that, have you tried the thing? Which thing? That thing? Which that thing? It's right there. Ah! I don't know what thing! Under there. What? Under there? What are we in middle school? Are we in middle school? Is that where we are? We're in middle school. Okay. Alright, so this one should still break it. Just say it. Just say it. Say which, though? Underwear? Underwear! You got me! Oh, man! Woo! Woo! Oh, ring that bell! Oh! Thanks for that, though. These buttons have been collecting dust over the last several sessions. Yeah. Okay, so now if I run this, yes! Can't send optimal amount. Excellent. Alright, so now I still have... There's still going to need to be a diff 3 here. So we're going to have one more. Okay. So here's where we need to sort by highest value. we go. So what's up, chat? How y'all doing tonight? Or this morning, whatever it is, wherever you are. I guess technically for me, it's morning. All right. I don't know if we need the leftovers array anymore. We might be done with leftovers. I think we are. Just going to comment that out. And then okay, so now we should be passing again. Oh, whoops. Oh, and then total diff needs to go. There we go. Sweet. All right. All right, then to do. Okay. Okay. All right, now I need to make another failing test here. Do, 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 do. All right, that is... Do we not have a better way to do that? Because that seems about right. There is a minimum... Anytime you have to do a try-catch, there's always a minimum complexity that you just can't avoid. Okay. Wait a minute. That's not actually it. Looks like it should be, would be, but it's not. It's right here. Oh. Let's see here. Where do I need to go? Where am I putting this stuff? I'm putting it right here. Wait, where was that error that I was just looking at? No. Alright, so if we had an error, if it was expected to go... Okay, got it. So first, let's go figure out what our error is. Which this error should have been caught earlier, because we should have found out whether or not we have enough coin for something, because we already do a coin selection ahead of time. So this really is an error that the developer... There shouldn't be a position in which the amount of coin... but then there's always this edge case of whoever came up with the transaction fee mechanism just did not think this through. The transaction fees and money that you send to people, that just shouldn't be the same. It's different, you know. It's like, okay, this is one thing that the banks got right. Okay, and that credit cards got wrong. The banks charge you a fee every month. And it doesn't matter how much money you have in your account. You get a $10 fee in order to have a bank account. Whereas the credit card, this is I mean, this is just, God. I mean, imagine if you went to the store and the amount you had to pay was different based on the number of coins. Literally, you know that imagine there's a per coin charge. There's a per unit charge, and so you want to pay $25, and you have a 20 and a 5. But because you have a 20 and a 5, now the cost is actually $26. But if you throw in $1, or that's too much of a difference. But now the cost is $25.15, or something like that. So then you add in a quarter. It just, yeah. Ugh. I don't know what it is, but it's just, yeah. For every value that you send, the cost of the transaction increases relative to the number of. This is not a good system. Ah. Wait, did I spell inconceivable wrong? No. Gosh. Gotta be careful spelling words. Okay, so E, insufficient funds. We go back here, send cash like, and then we're expecting this to have the error E, insufficient funds. Alright, so we run it again, and we get a pass. Good. Okay. Oops. All right, so now we need to get back to the original value. All right, let me thin this out a bit because there's a lot of stuff in here that ended up not needing to be here. So let me go ahead and thin it out. Well, actually, before I even thin it out, if we got test passing, it is time to add just to stash some things at least. All right, because this is a big deal. Okay, so now that we've got that, let's thin this out, which should have no effect. Because we're only getting rid of dead code we didn't use, right? I'm starting to wonder if my former idea of... Oh, wait. Let me check on sound inputs real quick, because it looks like my sound is a little low versus the volume of the music. This happens every once in a while when things get messed up. No, looks like it actually should be fine. I might just be speaking quietly, or I don't know. Okay, what was I gonna say? Actually, there was one. Okay, this one. I do want to see what this... I want to get the summary here. Sorry, I forgot what I was going to say a minute ago. Yeah, it happens all the time. Huh. Let's see. That's not right. Total needed, total selected. We're definitely selecting more. Hmm. Hmm. Shouldn't those be exactly the same? I think that was a useless calculation. Okay. Ooh. Alright, that's actually a good number to take a look at. But this number doesn't actually matter. What matters is the next number that we need to calculate. So we need to get the... We need to get the total real value. Below max fee. Oh, here we are. There would be some way to do a rolling calculation on this, but I don't think I'm actually up for it. And we know what the cost of the inputs are going to be, but we don't really know what the cost of the outputs are going to be. So I think it's better... It might be better just to recalculate this. Hold on. Oh, right at the end. So before we do the final calculation... Was it right here? I don't know. There is a baseline that we kind of need to establish. God bless me. All right, the crude size is going to be okay, so there's our crude size. So we're going to say that our selected fee starts at some crude size. Because basically for every input we're going to have an output. That's the idea. I don't even know if that's the right way to go about it. Okay, again, I'm going to comment these out. And I'm just going to go for the simpler at the end. Let's see, what can we do? So let me think about this. So then we have to figure out of this. Okay, this is number of inputs. What? Alright, so now that's showing how many are actually there. Okay. Okay, so we gotta take the face value coins. Am I in the right file? Yeah, I'm in the right file. I just changed this. So here we are. Alright, so then remainder is going to be equal to send info. Devs never sleep. That's right. But dude, I gotta tell you, I'm just so... I'm both on the cusp of solving this, it seems like every day, but then I'm just so not motivated by this right now. It's really rough because I want to finish it, but I also am at the pretty much the maximum level of mental distraction. I don't know what I need, but I just feel like there's not enough Mountain Dew in the world. But I'm so close. I mean, I've just got to do the last couple of calculations and then basically the adjustment. So all of the really, really hard work is done. And I guess that's kind of why I just want to leave it alone right now, because I've only been working on this for an hour, but I did get to the point where, okay, the hard part, not the very hard part, just the hard part, not the very hard part, but the hard part that I'm going to be dealing with for now is done. This next bit is easy, but I feel like there's that sense of closure of when you've done something difficult and you've accomplished it. It's like, okay, let's go take a break. So even though I have not spent hardly any time on this yet tonight, I'm kind of in the, okay, let's go take a break mode, because the thing that I didn't get to finish the other day, I've now finished, and that was the hard part. And this part is not so hard, because all I have to do is just do a calculation, check to see if it worked out, and then if I can't actually make the transaction with the coins I've selected, then all I need to do is increase, or to get one more coin and then run the calculation again, and then get one more coin and run the calculation again. So basically I can do just a little bit more work here, and then I can basically just run it in a loop that says, hey, if it's not working out, just add the next, add a coin that meets the difference amount, and then rerun it. And then we can guarantee to get it right that next time. Actually, we don't have to put that in a loop. We can guarantee to get it right next time, because we'll know. Well, no, we can't. We can't guarantee it. We do have to run in a loop. I was going to say, because we know that if we select just, no, we don't. No, we don't. I was going to say, we know that if we select just one coin, then, and it's at least the value that we need, that it will work out. But we actually don't know that, because by adding a coin, we can increase the transaction costs. We know what the transaction cost will be for the input, but the number of outputs that may be necessary for that coin might be, well, on average, I mean, I guess we could just calculate the cost of, we could just go and say it needs to be this value plus the maximum number of, so the worst possible value that it could be is if we select a coin that's basically 999, right? So 999 translates to this, the worst possible value. Say this was it. Then the output fee, I think, is only 34. So it's not that much. So if we knew this would be a 2. I mean, this would be a 5, a 2, and a 2. And it would be that 4 times. So it'd be 12 outputs. So we could say 12 times 34. Really, we could just do 12 times min stamps times stamp. That's the way that we could reduce that we wouldn't have to run it in a loop, because we could guarantee. Well, no, we still have to run in a loop, because the person there's always going to be this edge case. The person could give us a coin that's 99.99. It doesn't even make any sense. It doesn't. But if their coin was that specific, I mean, it's astronomically unlikely. But again, if we just put it in a loop, then it doesn't matter how likely or unlikely it is. If we put it in a loop and say, okay, if it didn't work out, then just try again with another coin. And then if that didn't work out, then just try again with another coin until we've exhausted the coin supply. If we get to the point where we just, I can't. Which makes me think that this one might actually not be necessary, this check, because the error that we actually want would be if we get this value and this doesn't work out. Oh, we need to return leftovers too, don't we? Because we do need to signal. I wasn't thinking about it this way. I don't know if I want to think about it this way. I don't think I do. But if we want to signal which coins have been used and which coins have not been used, then we need a leftovers array that we'd have to pass back. And then we would have to pull from the leftovers. Which I think from the coin selection that runs before this runs. Too many edge cases. Because then we'd need an outer loop as well. And our outer loop would have to check the amount of coins that it put in. And we'd basically have to throw an error. And the error would have to say, hey, it ends up that this is the actual value that's necessary. But that value is just, I hate the randomness. I hate this. I hate this so much. Okay, whoever designed the transaction fee system, this is so bad. This is so bad. And it's not really, again, I listened to the article that one of the core devs wrote. And actually, I think it actually was the article that I could not find. Because it went viral on Reddit in 2016, and I think I read it then, if I'm not mistaken. Or one that was very, very similar to it. Hold on. The resolution of the Bitcoin experiment. Okay. Here it is. Yes. This wallet, it's not that it's going to have private send by default. It's that it's not going to have fingerprinting send by default. If that kind of makes sense. So it's a different attack on the problem. All of the sends are denominated. So as basically without doing anything else, without actually doing any mixing, because there's a difference, there's an important distinction, a really, really important distinction between mixing and private send as they are loosely interchanged in the Dash community. So mixing is when you take coins and you put them into a process and you mix them with other coins and then you get out mixed coins. But there's a number of problems that I've mentioned before with the way that ends up working, and the outputs that you get aren't actually useful, and then they end up revealing all the information and blah 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 blah. So the mixing is not the thing that's necessary. The mixing is actually auxiliary. What's necessary is the other component, which in that implementation is called private send, but what this implementation calls it is just send. Or alternatively, cache-like send. And that is that you need to select denominated coins so that you use the fewest number of coins. Because it's not even about getting the change back per se. It's about selecting fewer coins of discrete values. Because if you don't have discrete values, then it's not cash-like. Cash has discrete values. And so the benefits of cash, if you want that to carry over into a digital system like Dash, you actually need discrete values. And this is something that the CoinJoin implementation does not do well, because the discrete values actually don't carry the value that's necessary in order to transact them. So you end up with this. We know it's just, yeah, there's layers of problems, and what I'm trying to do is say, okay, well, given the way things work presently today, how can we provide a sending mechanism that, as it gets adopted, will tend towards cash-like transactions? And the number one thing is that the optimization that comes out of Bitcoin. Oh, and let me finish putting this out here. The resolution of the Bitcoin experiment. Okay, so there's a problem, because the mindset of Bitcoin is that transaction fees are going to be super duper expensive. So you have to save on transaction fees as best you can. Digital cash has vestigial transaction fees. I don't think that the people, they reduce them to near zero, but not zero. And you can't reduce them to zero, because then the network gets abused. But they need to be reduced to zero. What needs to happen ultimately is that the ledger needs to be non-permanent. You need to be able to verify that something happened based on signatures, but things that have happened in the long past, you don't need a global ledger of that lasts for years and years. Because if you needed to prove it, you only need a signature that is... You only need to be able to prove a series of signatures happened. You don't need you need the conclusion of the series in order to prove that the thing happened. You don't need the entire series, right? That's the whole idea of the pub key hash, which is used for the payment address as it stands right now, is you don't actually need the public key. You just need a deterministic value that was based on the public key. So you don't need every transaction stored forever with all of its details. You just need the result. So you can collapse the transaction. So all the transactions, what I'm saying is you don't need to keep around the spent coins. The spent coins you can collapse away, and then you can rewrite a new transaction that aggregates the unspent coins. And then you can have a masternode voting mechanism that does the same thing that it does with block verification, but instead, or with mining verification, but instead do it on essentially this pancaking, this roll-up, this squashing verification, the same way that Git works and that other things work. So anyway, but it's a tangent, but the whole thing, it's all connected, right? But because we currently have transaction fees, and the transaction fees are based on the number of inputs, it makes it difficult to provide good ergonomics around denominating coins, because one, almost none of the coins in the ecosystem are denominated in a useful way. And then 2, the transaction fees are variable based on the denominations, but when you break change, you can't know ahead of time how much change you're going to break because you don't know what denominations are available. So as the system continues, you'll have more and more of denominated values and fewer of non-denominated values. So it will tend towards the ideal as it's deployed. But in the period where it's starting to be deployed, it still has to work well. It doesn't have to be the ideal, but it has to work well. And so you have these scenarios where a coin that has a value, which is extremely common right now, of X point Y 9 repeating, because that will happen anytime a coin is transferred twice, it'll end up with an X point Y 9 repeating. Because if I want to transfer you 0.5, then when you transfer it, then it becomes 0.49 repeating. And that actually makes it the worst possible value that it could be in terms of being able to denominate it, because it has no excess of it doesn't include, it's not spendable. 0.5 is not spendable because you need about, at the end of the line, you need 200 sats, which is 2 millionths or 100,000ths or 10,000ths or whatever it is. It's hard to count the zeros, but you need that amount in order to do the transaction. So a coin is always less than than its face value, and so that's all related to what I'm doing here. Anyway, let me catch up on your actual comment. Okay, what's fingerprinting? Fingerprinting is the broad term that if all of the transactions on a blockchain are public, so if you want to know information about a person or a network of people, such as relationships between people, especially people that have an ongoing relationship where they transact because they have a relationship that mirrors that of friends or mirrors that of coworkers or whatever, employer, employee, or that has that type of characteristic to it, the payments will have a cadence that dictates that. And the canonical example of this is that if you are looking at encrypted messages going back and forth within a corporate organization, you can tell what the hierarchy of the organization is based on pseudonyms without knowing what's in a message, because the cadence of messages passing back and forth will tend towards, you can tell who is making top-down decisions, and you could tell if someone is informing that person before those are broadcast. So likely the person broadcasting a message is going to be maybe in HR or in an executive secretary position or something like that. But the executive is going to have some communication, and then the communication is going to promulgate, and then other heads are going to do, they're going to communicate. And so you can determine the structure of the organization from the cadence of communication without knowing anything about the communication itself. Anyway, so that's what I mean. Fingerprinting, you can tell payment is a form of communication. So you can tell just by being able to associate all of the things. And then when change is given back, or when lots of coins are sent, it describes the relationship of the money. And we don't want that. Cash is not that way. Cash does not carry very much information about the individual. Whereas in a digital ledger, a lot of information about the individual is carried, because there's going to be similarities in payment amounts that can be traced backwards in time, even if funds have been mixed. In practical conditions, I agree that in the theoretical conditions that you can't reverse those funds. Okay. What? Hold on. I just got a message from my wife. Oh, okay. Yeah, she's got a bad, well, we don't know what it is, but it's maybe a cold. I don't know. She doesn't ever get sick, and so now she's getting sick to the point that she's experiencing pain, which for a lot of us, we know what that's like. We know what it's like to have a sore throat that's so bad that your ears hurt. My sister just came and she flew to get here, and my sister picked something up along the way, and then she gave it to the whole family as a gift, as well as she got it herself. But my wife initially seemed to not catch it, but now she seems to have the worst of it, which it's probably because it's an East Coast based virus, the one that's developed over there, which I've already had those as a kid because I lived on the East Coast, whereas my wife has only been on the West Coast. So she's never gotten whatever this illness is, whatever variant of cold or flu or whatever it is this is, she has never got it before. Could even be strep throat. I don't know. We'll find out. Anyway, so if I pay for a coffee with $1 million wallet, will the person who receives the transaction be able to find out how much money I have? So that is not a particularly interesting problem to me, but that we would like that to not be the case, but this is one of those examples. I wish I could find let me see if I can think of an example off the top of my head that gives you an example of what this example is like. In reality, this isn't the thing you're concerned with. That's what I'm trying to get at. This is not realistic. We're not realistically concerned about people finding out how much money is in our wallet. We're realistically concerned about people denying us the ability to pay. Because you are not... this question that you have is one of the canonical questions, or maybe canonical is not the right word. It's one of the standard questions. But the question is wrong, because this isn't a problem that we have. So it's hard for me to describe this. In the normal use of your wallet, the coins tend towards some manner of fragmentation presently already. So the wallet value, so you take your 12 words, that's your wallet. You use a software wallet to calculate payment addresses from your 12 words, which is your actual wallet. And it doesn't matter which software you use as long as it follows the spec on those for the 12 words. So you have your actual wallet, this is the 12 words, mistakenly called the recovery phrase, because it's not the recovery phrase, it actually is the wallet. It's just, it's a little easier to message it as recovery phrase than as, wallet phrase, I guess, what makes it, but it's the wallet. It is the wallet. Okay. So you have that. You use some software. You put those 12 words into some software, or it generates it when you use the software for the first time. The wallet software can create a wallet for you. And then you have an infinite number of payment addresses that come from hashes and permutations on these 12 words. If you aggregate all of the unspent coins that is your wallet value. But someone is not necessarily likely to know what the value of your wallet is. They're likely to know what the value of a given coin is. So if you were to spend a coin, and typically the selection algorithm is spend the smallest coin that's slightly larger than what you need to spend. Because the thinking is that you want to send only one coin if you can, because that lowers the transaction fee. This goes back around into the whole conversation coming full circle again, back at the transaction fee problem. Realistically, this is not necessarily what we want. We want there to be few coins, and we want there to be ideally no change, no return coin in the system where the coins are fingerprinted by the values, because they have a bunch of decimal places that are not that are random, and in this case random means that it's a signal. Normally random is noise, but this is a fingerprint because the value is distinct and easy to trace and to follow. Anyway, so if I send you some amount, you know how much. So if I have $100 bill and I need to pay you a $1 and I give you the $100, this is the way to think about it. So I may have my let's think of a physical wallet. In my physical wallet, I have lots of bills. I don't need to show you all of the bills that are in my wallet. Unfortunately, with a digital wallet, the ledger, you can see any money that's related. You can see how it's related because you can just walk it back. But, so so here's the thing. If you had gotten paid $10,000 and then you broke up that $10,000 and then you spent some of the $10,000 and then you broke change on some of the amount that you spent, somebody can walk it back to where it came from. They can walk all the way back to where it came from. So in that sense, they could know that it was likely that you received $10,000, but they don't necessarily know what of it you still have. They could just see that an address, a grandparent of the address that contained the coin that you sent them contained this $10,000. But let's ignore that for a minute, because again, like I'm talking about here, if this algorithm is adopted, then as it's adopted, solely by being adopted, this story gets better over time. And as Dash stays within the Dash ecosystem, rather than Dash going straight out to a US dollar payout, right? But so when you okay, so you have some number of bills in your wallet. Let's get back to that. And maybe you have $10,000 worth of bills in your wallet. But they don't know, because your wallet, you're opening it up and you pull out a $100 bill. Now they know that you at least have $100 because you're giving them a $100 bill and you're asking them to break change for you. And so at that point, in a cash-like transaction, they would give you back some 20s and a 10 and a 5 and a few ones. And that's how they would break change for you if they had the change to break. They might give you a 50 and a 20 and another 20 and then a 5 and then 4 ones. Yeah. Or 2 twos. But they would know because they are breaking the change for you. And that's how it works in a digital a ledger-based digital currency, is that they're breaking the change for you. It's just they're guaranteed to be able to break the change, right? So they can see whatever the value was that you sent. But this is not a real problem. But let's go on with this. So they can know that you had $100. But this is the same way that it would be in the cash sent. So ideally, you would only want to send the amount that you're going to pay, and you would want no change back. And that would be cash-like, because you can have the right amount of change on hand. That's acceptable. And it wouldn't reveal any additional information, because all they need to know is that you have enough to pay them. They don't need to know that you have more than enough to pay them. So if you can get a value that's very close to what you need to pay them and have little to no change, then you do well in that regard. So if I explain this thing a million times, I don't know if I'll ever be able to explain it any simpler. But is that helpful? But the problem that I'm concerned with, I'm not worried about the coffee shop owner knowing that I have $100. I'm not worried about the coffee shop owner knowing that I have $10,000. What I'm worried about, it's not yes or no, it depends. Because you have to be more clear. But what do you mean? What if you have $1 million? What do you mean by $1 million wallet? What do you mean by this? What manner of coins? What was the process? Are you talking about and at what stage, right? Because if you have $1 million coin and the first transaction that you were to ever do with that $1 million coin was using this software, yeah, they're going to know that you have $1 million coin. Now, if the first transaction you were to do is with yourself to break change on the $1 million coin, and you were to break it into lots of 1,000 coins, and then some 100 coins, and then some 10 coins, and some 1 coins, and some 0.1 coins, and then the variations in between, a few 500s, some 200s, some 20s, some 10s, some 50s, some 5s, if you were to break change for yourself, and if you were to just break change for yourself a couple of times, then no, the coffee shop owner, the plebe, wouldn't know. But if this were your first ever transaction, if it's a plebe, no, they wouldn't know either, because the plebe is not going to be running software that is going to tell them what. Now, if it's one of those YouTubers that does investigative journalism around cryptocurrencies, would they be able to tell? Yeah. So, I mean, it's a very much an it depends scale, because you have to define some starting and end point. You have to give a scenario, because the mechanism of sending in of itself. So let's say, for example, you have $1 million in your wallet, whatever that means, because the term wallet is ambiguous and overloaded and is really unclear. You probably mean software. When you say wallet, you probably don't mean your wallet. What you probably mean is software on your phone that analyzes or interprets your wallet, which is not your wallet, it's the software, right? So that's like the difference between your clothes and you. You wear clothes, you're inside of the clothes, but you're you, and the clothes are the clothes, and they're they're fundamentally, you could put on different clothes and you would still be you. Right? And that's kind of the same thing with a wallet. Like, your wallet is the 12 words. You can put it in software on your phone or software on your desktop. You can use different algorithms for how to send coins or how to break them up, but that's not your wallet. That's software making choices in the same way that you could make these choices. So there is not a simple yes or no to this, because it requires context. If you were to take $1 million, you were to run it through a mixing process, and then you were to combine it together again into $1 million and then send it, well then, yeah, the person knows how much you have, right? So and that actually is sometimes what happens, because the mixing process will denominate things into large values. Typically, it denominates them into values that are too small, but depending on what you have, if you're trying to mix 100 and you're mixing the 100 back and forth, well, at the end, you still have 100. So are you trying to, is the concern about the value of the coin, or is the concern about the nature and history of the coin? And I think that in general, the value of the coin is not really important, especially not of an individual coin. And I don't think that there's anyone who would want you or suggest that you put all of your value into a single coin, because you have a wallet with literally 4 billion addresses, or 2 billion. Well, no, it has far more than that, because it depends on where you delineate, how you delineate the path. But yeah. Now I know why you have trouble sleeping. Why is that, Kiwi? Why do I have trouble sleeping? Because I can't come up with yes or no answers to questions? Dash is not really private, just obfuscated. The way that most people use Dash is not even obfuscated. The whole idea that Dash is private comes from basically one of the Dash improvement proposals that was implemented in one client and nowhere else. So, yeah, most of what you've been told about Dash's privacy is a lie, in the sense that it's not actually implemented. It is a specification that can be implemented, but in the general case, unless you are using the Dash Core desktop wallet for everything that you do, and the other people that you interact with are using that for everything that they do, there's basically no privacy in it, more so than anything else. Now, there are some arguments about, you could pull some money into Dash, and then you can take it out of Dash, and then you could put it back into something else. But even there, it's like, if you have $1 and then you break it into 10 million pennies, and then you see that 10 million pennies recombine into $1, it's like, it's not hard to tell this is the same 10 million pennies. Or, sorry, I don't mean pennies. I meant millionth pennies. Because, it's 0.000001. It's like lots more. Because in dollars, we only have 2 zeros. But in Dash, we have 8 zeros. So my point is that if you think that you're gaining some sort of privacy by taking the Play-Doh and putting it in the blender, and then taking it out of the blender and then putting it back into a ball, you're not. If you mix something and then you just recombine it into the same form, you didn't mix it. So anyway, but I am very concerned with the ability to have a cash-like transaction. I do not That again, with this, the resolution of the Bitcoin experiment, I'll post this article yet again. Give that a listen if you want to use Speechify or something, or give it a read. But the key thing is that the people who took over Bitcoin were very interested in Bitcoin not fulfilling its potential. The people who took it over very much wanted it to not succeed as a digital currency. And, they were very forceful and aggressive in making sure that that didn't happen. Let's see. Wait, what is that? Oh. Oh, bless me. Anyway, what was I saying? Yeah, the whole yeah. But I want to say this in the defense of Dash. The ethos are in the right place. The code isn't there yet. I think that it needs to be exposed that the code isn't there yet. I think that needs to be incredibly well known and understood. We need the code to get there, if it's going to accomplish its goal as being digital cash. And if it's not going to accomplish its goal of being digital cash, I don't personally have any interest in it. So my interest is in it getting to that point. But I think that there's a big distinction between a crypto nerd's wet dream and what people who buy and sell stuff need. And it's really easy for people to get lost in the theory of it. I mean, even me with this whole coin selection thing. And to some extent, I mean, we need to have something better than what we've got. And I think this alone accomplishes that. It could be way better. But there's some area, well, okay, like I was saying before, if we were to solve it, we can solve this problem perfectly. It can be perfectly solved. But not really. We could do a brute force of all the coins that are available in your wallet. It just would, take minutes to figure out how to send a very, very small amount of money, because it'd have to go through every possible permutation of hundreds of coins or thousands of coins. Okay, in that case, maybe it wouldn't be possible to brute force it, depending on how many permutations there were. If there's trillions of permutations, it may not be brute forceable. If there's millions of them, then it might be. But when it gets into billions and trillions, then it starts to get a little more difficult to do the calculations. But there's certainly a best effort that's better than average. Okay, anyway, I'm going to think on this. Oh, it reminds me of Linux times. So many forks, but ultimately they all want to be the next OS. There are not very many forks of Linux as far as I'm aware. I am aware of 0 forks of Linux personally. But I know that there are a lot of init systems, or there were. I think we're back down to 3 again of sysvinit, the old one, OpenRC, and oh gosh, I'm blanking on the name of System D. And I know that there's a lot of combinations of software packages, but Linux, I don't. Well, I guess I think Orange Pi has their own fork of the kernel that's a semi. Yeah, it's like it's got stuff that doesn't go into mainline, but the GPL kind of prevents forking in a way. Distros, yes. Yes. But these are actually forks, not just distros. So distros would be things like the Coinbases. They're not implementing new technology. They're providing a skin on top of the technology. So Dash is a fork of Bitcoin. It inherits many of the same flaws, but it is fundamentally changing. Some of the other ones are literally just twiddling bits, like Litecoin. It just twiddles bits. It's a fork in name, but it's not really a fork. It's just like they changed some variables and the logo. It's not a fundamentally different project, or Doge for that matter. It's Doge is not a fork. It is a fork, but it's not. It's the same code base. Anyway. Okay, so if I get through here, I need to look at that remainder and I need to check the denomination of the remainder, and then I need to see for the original. Oh, I have to see how many inputs there were total. All right, the coins, and then how many outputs there are going to be total. So what I know about these outputs, I think the send info already had the denoms, if I'm not mistaken. Send info. Let's take a look at where that came from. Send info. I think it has the denoms. Let's see if it does. It doesn't have the denoms. So when we go back here to send info, and this needed okay. Okay, so remainder here. This might be a different remainder. This would be change. Okay, and so what do I need to do? So we can say stamps should be min stamps times stamp. Okay. So basically, I don't know if I want to do that yet. Okay. Oh, I need yet another way to calculate this, which I was not anticipating. Okay. Yeah, this is something that I didn't work out earlier. But now I need another function, which I'll need another test for, which will be, how do I break these down? Let me see. Did I already have... Denominate coin. Okay, so the problem with my existing methods is that they give back the ideal amount as if it's sending if it's a single transaction, not the amount for, because there is the case where it would be more efficient, if I consider all the coins that I'm sending, it might be more efficient to send out a single 10, but because of the nature of breaking change, I might actually need to send out 2 5s, where it would, you know that one of the 5s is change because it's the non-optimal amount, potentially. But I think another thing that we need to be able to do, not necessarily right now, but with this, another thing that we need to be able to do is have the ability to scan and say, I'm low on 5s, send me some 5s. I'm low on 10s, send me some 10s. So you could ask for the preferred, rather than the ideal denomination. You could suggest a preferred denomination. It's going to add up to the same amounts. I could, if I need, and that doesn't change what inputs are need to be used. It just changes the outputs. So we need to have that ability at some point. But that actually comes into play here with this too. And it doesn't change our calculation, because our calculation is based on the ideal, but the actual output could be based on what's needed. Okay, let me think about this then. So we have the send vals. Those are the values that we want to send as we want to send them. So that actually should, maybe not. All right, so there's our send vals, and then okay, yeah. I'm going to write this right here, but this needs to be its own function. So maybe I'll just write a function in line. I'm not sure where the function needs to be yet, so maybe I won't. I'll just keep going. So close. We're so close. I'm not going to be able to make it tonight, though, honestly. I'm going to have to go to bed and continue tomorrow. I just need to I need to get to a good point of closure tonight, though, so that I'm not left in a limbo state where I'm like, "Urgh!" Okay, change. Joe's fault. He asked the stupid questions. No, the questions are good. It's just I'm really anxious about this. I think anxious is the right word. Just agitated. Just. Urgh, urgh, urgh. header size, input size, output size. Okay, let me think about this. So we need to grab the total amount of Satoshis in what we've found so far. Stamps value. We need at least min stamps. Fee starts with the header size, and then the fee is the output size times sendval size, and then whatever the coins we've selected, the fees are the input size, and then that's it, right? Fees are header size, input size, output size, or was there something else that's part of the fee calculation? Let me go back up here and see. I think it's just header size, input size, output size, because if we add these together, that's 3, 5, 8, 9, 193. Yes, that's the full size right there. Okay. So here, all right. I always forget how to use splice. I don't think I've ever met someone who remembers how to use it. Okay. Let's see. Huh. Oh. Okay. What do I do? Loop-de-loop. Okay, so we do have a problem because in this previous one, I thought, oh, we don't need the leftovers. Alright, how do I get these things sorted again? No. Alright, so it's either going to go on leftovers. Leftovers is going to get overwritten. Okay, that's good. And then here. And this currently is in descending greatest to least. And if we have to enter into this, then we're going to need to sort it the opposite way. Alright, let's try this. Let's see. And then there's the cost of the change. Okay, if change is greater than... Okay. Ugh. This feels horrendous. But I think this is going to yield the correct calculation. Okay, this is actually not going to be quite right, because we still have to change the change. Okay, that looks... Oh, whoops. Hold on. That's not right. Okay. Now we need to figure out... goes. All right. Let's see here. Okay, if wait, would this even be real? Change adders. Okay, I think I've lost the ability to really think through this further. Because now I'm down into the... But this is not the coin selection problem. The coin selection problem has now been solved, thankfully. Or solved in loose terms. that is not the thing that I'm working on. I did wrap that up earlier to an acceptable degree for all, current purposes. Now we're just back to the cyclic fee calculation problem where, in order to know the minimum value of the well, we're not even really calculating the minimum, we're still trying to be generous, but because we now have the coin selection, the coin selection in of itself, aside from the hard part of the coin selection, once the coin selection has been done, we have the same problem that we've had with transactions, where before, the size of the transaction is dependent upon the size of the signature. For these calculations, we just ignore that. We say, we're just planning on it being the maximum size that it could be. So it's always going to be 193. It's never going to be 192 or 191. That's fair, especially for the nature of this calculation. But we run into the self-same problem that we figure out how many coins are going to be needed for the change, and then based on the number of coins that the change needs to go into, we may or may not have enough change in order to form those coins. So that's the current frustration. And then and I'm trying to figure out that, because the other problem is, okay, well, say that we okay. So the problem is, there's a difference between the total amount of change that I have. Let's see. Coins, so push denom info, then get the change again. Okay, so we're going to calculate okay. So okay. Current. So if the change is greater than the min change, so stamps count. Oh, is this even right? Okay. I can't restructure this try-catch block in a better way. Okay, so this is what we're trying to figure out. So change info. Changes above the amount of min change. I'm a little confused about this. I'm just going to leave it. I think I'm going to leave it for the morning. Okay, because now cyclic flipping calculations. Okay, let me walk through it one more time. So, we're trying to get the total amount. We've done a coin selection, and we've picked coins that are relatively good, and maybe we'll need to pick one more. We don't know. But at this point, the coins are relatively good. We just have to figure out can the coins pay for themselves. And so we're going to start calculating the fee. We know the minimum number of coins that we need to send. And so we take header size and the output size being the size of the coins we need to send to meet the minimum value. And then we go through the coins that we've selected, and then we say, okay, well, with the coins we've selected, what's not just the face value, but the whole value, including value that can be used to pay fees. And then what are the actual... Here's the fee. Each coin costs the maximum input size for the coin. So that's our fee. And then we say, okay, but we also, in addition to the fee, we need some stamps that we can send. So we need the minimum number of stamps that we can send, which is our stamps count, which is, yeah, all that. And then our change is going to be our total amount that we have minus the amount that we're going to send, because we have to send at least the minimum, and minus the fee, and minus the stamps. So if the change, I think I kind of want to change this around a little bit, where if let's change this around. So if change is less than 0, because if it's exactly 0, that's actually okay. Because this does account for every thing. If it's less than 0, if we don't have any more coins, then we gotta barf. Okay. But if we do have more coins, then we just push another coin on the stack and then we try to run the calculation again. And the coin that we're pushing is going to be the smallest coin. So we're chewing up small coins because at this point we're looking at fee values. We're not looking at useful values. So we're just saying, okay, just grab something small. But there's a chance that what's grabbed is bigger. So we have to account for both. That it could be smaller or it could be bigger. So then we have the change is greater than the minimum change. Where was min change calculated? I think that was up here. Okay. And the min change is going to be the minimum denomination plus the cost to add the output of that denomination plus the cost of some stamps for that denomination. So if the change is greater than the minimum change, because technically it could be greater than or equal to, if it was equal to the minimum change, then that's okay too. So greater than or equal to, then we're just trying to figure out let's see. I don't know if this actually matters. Because if it's greater than the minimum change, then it doesn't really matter what the value comes out to. In the worst case, it's just split up and becomes fees, right? But it could be greater than the minimum change because we have to force it to go into coinage at this point. So if it's greater than the minimum change, maybe it should just be if it's greater than 0. Okay. This is where I need to pick up. It's just if the change is greater than the minimum change, I can't. Recursion's so hard. I don't know if this actually matters, because I think what matters is that I'm going to have to do one of these denominate self-pay type calculations. I think I'm going to have to copy that function, make a slightly different version that's for the payment. Or maybe not. This has a slightly different bit to it as well, because we don't actually have to calculate the inputs for this one. We only have to calculate the outputs for this one. And so, yeah, so maybe a slightly different version of that function that doesn't calculate the inputs. Anyway, I'm out. This is coming so close. It's coming so close. It's coming to an end. And then we can take this whole thing and we can finally do our dry run. Okay, parse coin. Parse, denominate that coin. Because what we're trying to figure out... Okay, let me take this one second further. Okay. So, it should not be possible for the coin to not self-denominate. Because it at least reaches the minimum threshold. Change is greater than or equal to 0. No. So if change is greater than min change, yeah. Okay, so if the change is greater than minimum change guarantees that it can't throw. So we can get rid of this. Because it guarantees that it meets the minimum criteria of, well, that's not entirely true. let's see. There is a singular edge case here. And that is okay. So we are going to make it be, for the sake of making the calculation simpler, we're going to require it to be about 150 sats larger than what it really must be. But it makes the calculation a heck of a lot simpler. So we're doing that. Okay, now it's guaranteed. Because here's the thing. With the self-pay coin, I was calculating it from the perspective that the coin is going to be sent itself. Right? This makes sense. So, but in this scenario, the coin is actually, the overhead is already considered. But it's okay, because if we can't use this, we're just going to break it down smaller, so we don't, and then we don't actually need that calculation that we did for the maybe it was the send value calculation. It's not actually, because it was the face value and the high face value, but here we don't care. Oh, we don't need to worry about that. Alright, so, and then here we don't need to worry about this one, because this is already being done for us. Okay. I'll print this out, and then I'll be done with it for the moment. Well, that doesn't look right. That looks right, at least an approximation. Well, not quite. Well, kind of. Let's see. I don't know how far down this goes. All that. But, I mean, there's a whole other aspect here. Okay, so I still need to write one more function because I still do need to write the bit that it calculates for even distribution of stamps. So this is still not quite right, but I need to step away from it again for a bit. Change denom info. Okay. All right, let me just take a look one more time. Okay, so this change does not make sense. Let me just throw this together real quick. Three, 1, 5, 8. 2, 3, 1, 2, 3, 1, 2. 3.15. That's changed for the total selected. Oh, there's what's wrong. Okay. See if this looks a little more reasonable now. 2, 2, 2, 2, 2. Yes. Okay. So. Okay. Okay. This is... Okay. This... I think I am officially past the annoying tedium with this one to do out of the way. This is going to be easy, though. Because I just need to take... I've guaranteed that the minimum number of stamps are there because as I'm going through the loop, I'm calculating as I go. What wallet are you working on, Dashcore? No, this is not Dashcore. This is the Dash Incubator wallet. And the goal of the wallet is to have a built-in, well, a number of things. One, to be able to do payments with XPubs. XPub payments is a big part of it, but a big part of it, once you have XPub payments, you have the ability to do cash-like send. And so those two things go hand in hand. And so the thing I've been breaking my brain against for about 2 weeks now, maybe 3, because the week before was only because I was mostly not around the week before, but has been figuring out how to do coin denomination and coin selection, which coin denomination is really simple. While there are some deceptive part, it's not as simple as it seems for some things, but relatively simple. Coin selection, on the other hand, is incredibly complex. It's far more complex than I had imagined, just by not just one, but multiple orders of magnitude. And again, the coin selection I'm going for is a coin selection that solves the problems that we actually have with coin selection, which is that coins tend towards usable small amounts, so we need to actually favor spending small coins that are useful for a given transaction that will generate very little change. But we also have to, so that the basic of it is with this is that the more people adopt this algorithm for coin selection, the better the coin selection will get. Basically there will be no need for mixing. Mixing could still in some cases could still be useful, but what's necessary is to have good coin selection and good sending, because without good coin selection, then it really doesn't matter whether or not you've done any mixing. The mixing is of no value if you don't select coins in an appropriate manner. There's literally no, if you ignore the selection algorithm, then there's literally no benefit to mixing. Just there isn't. But if you have a good selection algorithm, then you don't need mixing, but mixing, for some people, for some use cases, would make sense. But if we can get greater than 50% adoption on a way of sending that's a good way of sending, then then we're golden. So that's what I've kind of been working on, Kenny. Let's see here. So change denominator. So I just have this last little bit. I know I've guaranteed that there will be enough stamp values in the coin values that all the coins will be transactable. So this is another thing, is that this, when it sends, it uses the dust values to ensure that the money that's being sent will have enough dust to pay transaction fees several times. So, and this is also necessary in terms of having an economy. It's also necessary if you want to be able to mix easily and well, then one of the things that you need to do is simply include the transaction value in the coins that are being mixed, and part of the mixing process just redistributes the transaction value. So this will afford itself, or this will lend itself towards a far more efficient mechanism for mixing. So it would not be incompatible with the present mechanism for mixing. This coin selection will still work for that. Well, other than that, it doesn't actually take into account rounds, but again, it will tend towards getting better over time. So the very first send that you ever do, the very first person, when I use this wallet for the very first time, once this is done and I'm ready to send, which I am eager to do, once I am doing that, being the very first person to have ever used this, I will only get marginal benefit out of it. But the more that I personally use it, the more benefit I will personally get out of it, and the more that others use it, the more benefit that we will all collectively get out of it. So there's immediate benefit as one person using it, but yeah, collectively. Anyway, so it's been a real brain bender because I thought, I don't know. I started out thinking that it was going to be much simpler than it was by at least a few orders of magnitude, by multiple orders of magnitude. The complexity, the complexity of what it takes me to figure it out. Yeah. But now we're down to the point where I know that they'll have the minimum number of stamp values, and so then I just need to do a final calculation. The final calculation needs to account for both collections, because one collection is going to be, I really should, I should do the denomination of the send before it goes into this. Yes, I absolutely should. That should happen before it goes into this. So that's going to be another to do. Is just going to be to move that little piece out. Oh wait, why is this griping? Oh, complexity is too high. No way. I could have never imagined. It's okay, we'll move out just a tiny bit of complexity at least. Thanks, Kenny. So getting the request question ahead of time, but okay, got it. Got it. I know what I need to do there. That's clear now. That's good too. And there should be some small amount of variation that we just put in here randomly. So we should not, okay. And we should not always seek the ideal. So the reason for that is that not all transactions are ideal transactions. And we don't want non-ideal transactions to stick out. So we should have some amount of variation as to whether we are going to pick any given denomination or not. So if we go around in the loop, that should probably be something like a 1 out of 10. So what I'm saying is we should not always make the ideal change. We should sometimes make slightly less than ideal change. So that when we have to make slightly less than ideal change, it's not as strong of a signal that it was change. Actually, maybe not, because again, as this gets used more and more, it's going to tend towards the ideal. It's going to tend towards you have the ideal amount of change at all times. Okay, anyway, I gotta get out of here, otherwise I'll explode. So, some cool stuff actually happened.
Do what we must because we can.
Actually, that fanfare was a little too strong, because that's the fanfare. We're going to play all the fanfares 6 times over when I finish this, when I get the dry run working. But this is so close. So close to selecting the coin. I mean, we pretty much have the coin selection. We just have a couple of loose ends left to tie up here. And then we can put it into practice. And no, it's not going to be optimal. It's not going to be ideal, but it will tend towards ideal as it gets used more among more people. But the initial bit will not be ideal, and that's okay. Anyway, I'm gonna go. Thanks for tuning in. Catch you next time. Adios.